Hello, everyone. Let's study together today other wet methods for removing sulfur dioxide from low concentration flue gas, desulfurization process, then dry flue gas desulfurization technology and comprehensive comparison contents of flue gas desulfurization process. First of all, let's take a look at other wet methods. Magnesium oxide method in flue gas desulfurization process. Magnesium oxide method has high desulfurization rate and can recover sulfur, avoidable solid waste, and other characteristics. In areas with coal resources it is a kind of competitive desulfurization technology. Magnesium oxide method can be divided into regeneration method, discard method and oxidation recovery method. First, the regeneration method. Magnesium oxide developed by American Basic Chemistry Company. The slurry regeneration method is magnesium oxide wet method. Representative process of desulfurization technology. The washing flow of its process is shown in the figure. Its basic principle is to use absorption of sulfur dioxide by magnesium oxide slurry, formed containing magnesium sulfite and a small amount of sulfuric acid. Then, it is sent to a fluidized bed for heating, when the temperature is about 1143 K, releasing magnesium oxide and high concentrations of sulfur dioxide. The regenerated magnesium oxide can be recycled. Sulfur dioxide can be recovered for acid production. The whole process can be divided into absorption, solid separation and drying of sulfur dioxide. Three main processes of magnesium sulfate regeneration. Second, discarding method is also called magnesium hydroxide method. Desulfurization process is similar to regeneration process. The difference is the regeneration method. In order to reduce the burning decomposition temperature of desulfurization products, it is necessary to prevent the oxidation of desulfurization absorption solution. The law of abandonment requires forced oxidation, and promote, almost of magnesium sulfite is converted into magnesium sulfate. 3. Oxidative recovery method. Oxidation recovery method refers to oxidizing desulfurization products into magnesium sulfate. The desulfurization process is similar to that of discarding method. Similarly, magnesium sulfite is easily oxidized and characteristics of easy dissolution of magnesium sulfate. Forced oxidation of desulfurization liquid is also carried out, and a high concentration of magnesium sulfate solution is formed. The difference is that the magnesium sulfate solution after forced oxidation is recovered by the recovery method, filtered, to remove insoluble impurities. Subsequent to concentration, crystalline product of magnesium sulfate formed by crystallization. Magnesium oxide by oxidation recovery method. Desulfurization process is mainly composed of desulfurization system and magnesium sulfate recovery system consists of two parts. Then the basic principle of seawater desulfurization method. Seawater desulfurization technology for coal-fired power plants. It is a new type developed in recent years. Flue gas desulfurization technology, depending on whether other chemical absorbents are added or not. The process of using pure seawater as absorbent. Flaked hydro developed by ABB Company of Norway. Seawater flue gas desulfurization process is a representative. Second, add a certain amount of lime to seawater, to adjust the basicity of the absorption solution. So, first, let's take a look at flaked hydro. Seawater flue gas desulfurization process. It is to use the natural alkalinity of seawater for desulfurization. Then, seawater is usually alkaline. The natural alkalinity is about 1.2 to 2.5 millimoles per liter. This makes seawater have natural acid-base buffering capacity. Flaked hydro. The flow of seawater flue gas desulfurization process is shown in the figure. The process mainly includes flue gas system, seawater supply, and drainage system and seawater restoration system. Then, the flue gas discharged from the boiler is dusted, and after cooling, it is sent to the absorption tower from the bottom of the tower. and spraying wine evenly from the top of the tower. Pure seawater reverse full contact relaxation. Seawater absorbs sulfur dioxide in flue gas to form sulfite ion. The purified flue gas passes through the gas-gas heat exchanger. After heating up, it is discharged into the atmosphere through smoke map. The main structure of seawater recovery system is explosion tank. Acid seawater from absorption tower and adjacent area. The discharged alkaline seawater is mixed in an aeration tank. At the same time, through the explosion system to the pool. Blow in a proper amount of compressed air. The sulfite in seawater is converted into stable, harmless sulfate. At the same time, it releases carbon dioxide. Raise the pH of seawater above 6.5. After reaching the standard, it will be discharged into the sea. The second is the Bechtel seawater flue gas desulfurization process. Then, the Bechtel seawater flue gas desulfurization process is shown in the figure. Fresh limestone/lime slurry mixed with seawater in a regenerator. Natural seawater contains about 1,300 mg per liter. Magnesium chloride and magnesium sulfate are the main existing forms. Then magnesium reacts with lime slurry to form magnesium hydroxide. The absorption of sulfur dioxide is enhanced. Compared with limestone/lime wet process. Seawater desulfurization. Due to the process equipment without desulfurizer, production cost is relatively simple, and there is no subsequent treatment and disposal of desulfurization products. Its investment and operation cost are relatively low. However, due to the limited alkalinity of seawater, usually applicable to desulfurization of coal-fired power plants with low sulfur content, is mainly less than 1%. So, ammonia desulfurization technology. Desulfurization is based on ammonia water as absorbent of sulfur trioxide. The byproduct is ammonia sulfite. First, the absorption process. The flue gas passes through 3 absorption towers in turn. The sulfur trioxide is absorbed by the absorption liquid and formed amine sulfite and amine bisulfate. Second, comprehensive crystallization. Comprehensive by absorption reaction produced high concentration ammonium sulfite and ammonium bisulfate absorption solution. First, the ash filter is used to remove the smoke and dust. Then it reacts with ammonia in a crystallization reactor. At the same time, indirect cooling with water. Then, the ammonia sulfite crystals are thinned. Third, crystallization separation. Amine sulfite from the bottom of crystallization separator. Crystalline suspended solids enter centrifuge. Separate solid crystals as byproducts. The remaining filtrate is returned to the absorption tower for reuse. Then, the advantage of this desulfurization process is that the desulfurization efficiency can reach 99%, and byproducts can be obtained as chemical fertilizers. Then there is no waste water and waste discharge. Absorption of sulfur dioxide with ammonia, and the difference between other bases is that both cations and anions are volatile. Therefore, the recovery of both must be considered when designing the washing absorber too. At present, the regeneration method is the most widely studied method. The regeneration methods include pyrolysis, oxidation and acidification. So, pyrolysis means indirect heating of the absorption liquid by steam. Then, the sample sulfur oxide is released. The byproduct of this process is amine sulfate. So, the oxidation method is to avoid the problems existing in the hot alkali method are put forward. The purpose is to put all sulfites and bisulfites, oxidation to sulfate. Then, amine sulfate is the final product. Acidification is to add strong acid to and release sulfur dioxide from sulfite and bisulfite. Then, 2 products can be obtained by acidification. Is to release sulfur dioxide to make sulfuric acid, amine salt of elemental sulfur and added acid. Then, sulfuric acid, nitric acid and phosphoric acid can all be used to regenerate washing liquid. Dry flue gas desulfurization. The desulfurization product obtained is in dry form. Features: investment is lower than wet method. There is no need to install demister and flue gas reheater. Suitable for limestone with medium flow rate and high grade. Power plant application of source. Second, dry hair spraying calcium desulfurization. Dry calcium spraying desulfurization process was as early as 1970s, conducting development research in the United States. However, due to the low desulfurization rate at that time, it has not been popularized and utilized. Because the equipment of the spray cover desulfurization system is simple, low investment, low desulfurization cost and small occupied area, suitable for desulfurization transformation of old power plants. Desulfurization products are dry and easy to treat. Then the comb stripping process of flat spray cover is shown in the figure. The core of the process is easy core, which is to spray limestone powder on the meat of boiler hearth. Activation reaction after partial and furnace. Calcium injection desulfurization process for dry hair is usually applied to low sulfur. It is especially suitable for desulfurization transformation of old power plants, but it is less used for flue gas desulfurization in new power plants. Circulating fluidized bed flue gas desulfurization. This technology was developed in the late 1980s. It was first developed by a German company. The whole circulating fluidized bed desulfurization system consists of lime slurry preparation system, desulfurization reaction system, and dust collection and air induction system are composed of 3 parts. Its process flow is shown in the figure. The main advantages of circulating fluidized bed flue gas desulfurization are: the reaction residence time of desulfurizer is longer, and has strong adaptability to the load change of boiler, as 98% of the bed material participates in the cycle. Fresh limestone, accumulation of residence time of lime in reactor, it can reach more than 30 minutes. The utilization rate of lime is improved. The flow rate of flue gas in the reactor can vary from 1.83 to 6.1 meters per second. Therefore, the load of the boiler can be met. Changes in the range of 30% to 100%. But the current circulating fluidized bed flue gas desulfurization system is only available on a small range of power plant boilers. Application: there is still a lack of large-scale application performance. Then, fly ash dry flue gas desulfurization technology. Mix coal ash, lime and gypsum in a certain proportion. After steam curing, and enhanced activation, dry and prepare to have a diameter of 6 mm. Composition of cylindrical particles about 3 to 10 mm long. The characteristics of this technology are as follows. First, the desulfurization rate can reach more than 90%, and the performance is stable. Reach a certain level of wet desulfurization. Second, the cost of desulfurizer is low, conducive to environmental protection. Third, the water consumption is small. If drainage treatment and exhaust reheating are needed, the total cost of equipment is 1/4 lower than that of wet method. 4. Coal ash desulfurizer can be reused or used for other purposes. 5. There is no slurry system, which is easier to maintain. The equipment is simple and reliable. The basic reaction of coal ash flue gas desulfurization technology is as follows. Fly ash, lime, gypsum and sulfur dioxide react. Generate coal ash and gypsum. So, the special effect. First, coal ash and gypsum can accelerate desulfurization chemical reaction. Complete the reaction. Second, the desulfurization efficiency exceeds that of activated carbon. At the same time, it also has the ability of denitration. Third, low reaction temperature is beneficial to desulfurization, but it will make water gasification unfavorable. Increased influence, then the comprehensive comparison of flue gas desulfurization process is mainly factors to be involved. First, desulfurization efficiency. Desulfurization efficiency is determined by many factors. In addition to the desulfurization performance of the process itself, it also depends on the condition of smoke, such as the concentration of sulfur dioxide and the amount of flue gas. Usually, the wet process has the highest efficiency. Second, the reaction conditions of calcium flow are more ideal than those of wet process. Therefore, the calcium flow ratio in actual operation is close to 1, generally 1.0 to 1.2. Gas-solid reaction of dry and semi-dry methods. The reaction rate is slower than that in liquid. The calcium flow ratio is much larger. For example, the semi-dry method is generally 1.5 to 1.6. The dry method is generally 2.0 to 2.5. Third, desulfurization utilization rate. The utilization rate of desulfurizer. The utilization rate of desulfurizer refers to desulfurizer consumed by sulfur dioxide reaction and desulfurizer added to the system. Ratio of total desulfurizer. This factor is closely related to the calcium flow ratio. 4. Sources of desulfurizers. Most flue gas desulfurization. Calcium-based compound desulfurizer is used in the process. Well, because of its abundant reserves, cheap price, it will not cause secondary pollution to the environment. Some also use sodium-based compounds, ammonia water, seawater as absorbent. Treatment and disposal of desulfurization byproducts. Byproducts are sulfur and sulfur compounds, such as sulfur, sulfuric acid, calcium sulfate, etc. Influence on the original system of boiler. When wet desulfurization process is generally installed behind the dust collector in the power plant, it has little influence on boiler combustion and dust removal system. In the dry calcium injection desulfurization system, limestone is injected into the boiler hearth. Increase ash content. Then, the composition of the ash is changed. Change the running condition of the boiler. Slagging affecting the heating surface of boiler. Dust deposition, corrosion, wear and other characteristics. Influence on the adaptability of unit operation mode. Then, due to the need of power grid operation, the units of power plants may be used as air regulating units. Load changes greatly. Desulfurization device matched with air conditioning unit. It must be able to adapt to the characteristics of frequent start-stop of this unit. Therefore, all kinds of equipment of desulfurization unit can withstand frequent thermal shocks, have good load tracking performance. Then, the maintenance workload after the desulfurization system is shut down is small. The area size of flue gas desulfurization process varies greatly. It is very important to transform the existing power plant. Sometimes it even limits the application of some desulfurization processes. Then, in various desulfurization processes, the wet process of recovery method occupies the largest area. Semi-dry process is the second, and dry process is the smallest. Process and complexity. The complexity of the process flow is to a great extent determines the operation difficulty after the system is put into operation. Reliability and maintainability and maintenance costs. Flue gas desulfurization system is an auxiliary system of the whole power plant. It must have the characteristics of convenient operation and high reliability. Power consumption. Power consumption package. Power consumption, water consumption and steam consumption of desulfurization system. Process maturity. Maturity of flue gas desulfurization process. It is an important basis for technology selection. Comprehensive Evaluation Index of Coal-Fired Sulfur Dioxide Flue Gas Control Technology Comprehensive High Evaluation Index. First, technology maturity. Relying on desulfurization technology. At present, the development stage is divided into laboratory, pilot test and 4 stages of demonstration and commercialization. Technical performance includes desulfurization efficiency, treatment capacity, technical complexity, land occupation, energy consumption and byproduct utilization, etc., reflect the comprehensive performance of technology. Environmental characteristics according to the emission of sulfur dioxide from the treatment flue gas. Compare with emission standards for evaluation. The total technical investment and unit desulfurization cost of sulfur dioxide are selected as comprehensive economic evaluation indexes. That's all for today. Thank you all.